It is given that two small spherical metal balls having equal masses are made from material of densities ρ1 and ρ2, and the condition is given as nothing but ρ1 is nothing but 8 times of ρ2. So we can write density in the first situation is basically 8 times of density in second situation, and have a radius of 1 millimeter and 2 millimeter. So we can write the radius in second situation is basically 2 times of radius in the first situation. They are made to fall vertically from rest in a viscous medium whose coefficient of viscosity equal to eta and whose density is 0.1 times of density of second. So we can write the density of liquid is nothing but 0.1 times the density of second one. The ratio of their terminal velocities would be, our aim is to find out what about the ratio of terminal velocity. So first we can write the equation for terminal velocity, which is 2 divided by 9 into r square into g into density of object minus density of liquid divided by the value of coefficient of viscosity. Now in this two situation, the value of radius is different, density of liquid is different, density of object is different, and the value of coefficient of viscosity is same. So the factors which are varying is nothing but r square, and another one is density of object minus density of liquid. So we can write this terminal velocity is directly proportional to r square and directly proportional density of object minus density of liquid. So we can write the value of terminal velocity in first situation by terminal velocity in second situation is equal to r1 divided by r2 the whole square into density of object in the first situation minus density of liquid divided by density of object in second situation minus density of liquid. So we can just substitute the value, that is v1 by v2 is equal to r1 according to the relation. We know that if you're taking r1 as r1, then r2 is remember 2 times of r1 the whole square, and density of liquid is nothing but first situation is nothing but 8 times of density of second one, so we can take it as 8 ρ2, and density of liquid is given as nothing but 0.1 times the density ρ2, and ρ2 minus density of liquid again 0.1 times of ρ2. So we can write this is equal to r1 and r1 get cancelled. This is 1 by 2 square, which we can take it as 1 by 4, and over here we can take this ρ2 as common, and we can cancel these things. So this is going to be nothing but 7.9 divided by 1 minus 0.1, which we can take it as 0.9, or you can write this in the same as like 79 divided by 4 into 9. So we can write this as 79 divided by 36.